Alright, for the following polynomials, find the zeros, indicate the multiplicity of each zero, and find the degree. We've already done a lot of that, so there's just a few more. So, we need to find the degree. This is in factored form for you already, which helps a lot because it's already factored. So that means we have 3 from here, x to the second power, 2 from there, okay, and then x to the first, 1 from there. And then if you were to multiply all these together, this x to the third times this x squared times x to the first, we would add those exponents and get x to the sixth. So this guy is a degree 6. You notice it has a leading coefficient of 5. So even with a positive coefficient means both sides would be pointing upward. This didn't ask for end behavior, so we don't have to do that. But zeros, set the whole function equal to 0. Now, you know that x to the x minus 2 with a 3 on the outside just means there's 3 of those, okay? X plus 3 with a square on the outside means there are 2 of those, and then x minus 1. Now, one thing I want to point out to you now while we're thinking about it, x minus 2 to the third is not at all the same thing as x to the third minus 2. Okay, x minus 2 to the third means there's 3 x minus 2's. X to the third minus 2 does not mean there's 3 x minus 2's. Okay, you would have to solve this completely different than this. So I've seen in the past people get these two ideas confused on the test. This is the guy we're dealing with, which means we have 3 x minus 2's. Just like x plus 3 squared on the outside means there's 2 x plus 3's. Now all that's equal to 0, so I can set each factor separately equal to 0. So I get x is equal to 2 when I set those 3 guys equal to 2. I get x is equal to negative 3 when I set those 2 equal to 0, okay, and subtract the 3. And I get x is equal to 1 when I set that equal to 0. Again, what I'm doing is, in blue, x minus 2 equals 0, x minus 2 equals 0, x minus 2 equals 0. And each time I get positive 2. Here I said x plus 3 equals 0, x plus 3 equals 0, and each time I get x is equal to negative 3. And finally I said x minus 1 equal to 0, and I get x is equal to 1. Okay, so what does that mean? Well, that means that x equals 2 has a multiplicity of, it showed up 3 times, of 3. X equals negative 3 has a multiplicity of 2, and x equals 1 has a multiplicity of 1. Now if I were to go on and graph this, which this doesn't ask for, but if I were to go on and graph this, this is an odd multiplicity, which would mean the graph would cross over the axis. This is an even multiplicity, which means the graph would just touch the x-axis, and this is back to an odd multiplicity, which means the graph would cross. Now again, are you sure you understand where I'm getting the even and odd? I'm just talking about the value of this number, not the 0, but how many times it showed up. This is an odd number. It showed up an odd number of times. This showed up an even number of times. Showed up an odd number of times. Okay? And I think that answers all the questions there. So next problem, we're supposed to find all the zeros, indicate the multiplicity of each zero, and find the degree. The degree we can find first or last. Remember, the number of zeros that you have and the degree are equivalent. So this x to the third minus 9x, that's an x to the third. Okay, so 3 from there. That's an x squared, so 2 from there. And this is also an x squared, even though it's on the outside. You would do x plus 9 times x plus 9, which is an x squared, so 2. So 3 plus 2 is 5, plus 2 is 7. So this guy is a degree 7. Okay? And that could tell you all about end behavior, although it didn't ask for end behavior. Next is 0. So I set the whole thing equal to 0. Oops, I'm getting a little bit carried away there. Now again, I like this problem because x squared plus 9 and x plus 9 squared are two different things. X squared plus 9, all I can do is write that as x squared plus 9. But x plus 9 squared, I could just write that as x plus 9 times another x plus 9. So notice the difference. This I can't write out twice. That's just x squared plus 9. But x plus 9 squared means x plus 9 times x plus 9. Now I can separately set these equal to 0, or I can factor some more. This guy has the greatest common factor of x. Let's go ahead and pull that out. So that's x times x squared minus 9. So I pulled out that common x, and that leaves 2 of those, and then the minus 9. This x squared plus 9 does not factor. It is called a sum of squares, and that does not factor. These last 2 factors of x plus 9, I'm just recopying. This will factor again. So now I have x times x plus 3 times x minus 3. That is a difference of squares, and difference of squares always factors. Recopying everything else. Now it's time to set each factor equal to 0. So I have to set x equal to 0. I have to set x plus 3 equal to 0. X minus 3 equal to 0. X squared plus 9 equal to 0. X plus 9 equal to 0. And x plus 9 equal to 0. This is already solved. Here I subtract the 3 over. Here I add the 3. Here I subtract the 9. But I'm not finished because that's squared, so I have to take the square root of both sides. Remember, plus or minus when you use the square root as a tool, so x equals plus or minus. And the square root of 9 we know is 3. The square root of I we know is I, so that's plus or minus 3i, that's 2 zeros. And then x equals negative 9, and x is equal to negative 9. Now if I just list the zeros specifically, I've got x is equal to 0, x is equal to negative 3, x is equal to positive 3. X is equal to 3i, x is equal to negative 3i, x is equal to negative 9, and negative 9 shows up twice, so I'm not going to write it twice. So the multiplicity of each one of these first zeros, I'm just writing the word multiplicity abbreviated, alright, is 1. These all show up just one time each, except for the last guy. That has a multiplicity of 2. So if we were to graph these 3, which are actually x-intercepts, this would cross over the x-axis. These 2 you can't graph at all. Those are not x-intercepts, they're only zeros. And then this guy would just touch the x-axis and go back the other way. Next problem is an unusual problem. They're asking us to, this time, create a polynomial. Instead of me giving you a polynomial and asking you to find all the zeros, now I'm giving you zeros and asking you to give me the polynomial back. So it's a little backwards than what you're used to. It says a polynomial of lowest degree and has leading coefficient of 1 that has the given zeros. So x equals 2 is a 0. Now if you think about it, think backwards. What would give you 2 as a 0? If you subtract the 2 over, that will give you x minus 2 as a factor, right? Okay, think here too. If I add the 1 over, that will give me x plus 1 as a factor. This one's interesting. To get the x equal to 0, I'd have to subtract 2 and subtract the 1. So that would be x minus 2 minus I. I said 1, that's an I as a factor. And then this one, subtract the 2, add the I. That'd be x minus 2 plus I as a factor. Okay? So that is a polynomial of lowest degree that has a leading coefficient of 1. Okay, so the leading coefficient out here is 1. What the book likes to do is they like all of this multiplied out. I think it's worth doing one time. To show you how to handle this. It is easier to multiply these two together and then separately these two together, and then when you get those answers, then multiply those together. So we've got x times x. It's going to give me x squared. Then you've got x times 1. It's going to give me plus x. Negative 2 times x is negative 2x. Negative 2 times 1 is minus 2. Okay? That's that first set. Let's go ahead and come down and simplify that. That would be x squared minus x minus 2. Now this one's a little bit more work. Okay, so I've got x times x is x squared. X times negative 2, negative 2x. X times I would be xi, or ix. Negative 2 times x, negative 2x. Negative 2 times negative 2 is plus 4. Negative 2 times I would be negative 2i. Then don't forget, we'll do this in blue so you can see it, the last one. Negative I times x is negative xi. Negative I times negative 2 is plus 2i. And finally, negative I times positive I, this can get you, is negative I squared. That's still in parentheses over there too. Now I'm going to go back to red and simplify this. So I've got x squared. Notice I don't see any other x squared. So x squared. A negative 2x and a negative 2x. I don't think I have any other just number times x. No, that'd be negative 4x. Okay. Now, this gets interesting. Let's do this in a different color. How about green? I got an xi and a negative xi. Those cancel each other out. Okay. I've got a negative 2i and a positive 2i. Those cancel each other out as well. Okay. I'd already handled this one, and this one. So I'm left with 4. So I'm going to put the plus 4. Okay. And then this minus I squared. Remember, I squared is negative 1, so that's plus 1. So simplifying again, that's x squared minus x minus 2 times x squared, negative 4x, and then 4 plus 1 is 5. Okay. Now, I'm still not finished, by the way. Now, I've got to multiply all this out. So I'm using the distributive property. A lot of people call that FOIL, but it's not FOIL when you have 3 terms and 3 terms. It's just big. Okay. So I got x squared times x squared is x to the 4th. Okay, so I've done that. Now I'm doing x squared times negative 4x, be negative 4x to the 3rd. Then I'm doing x squared times 5, so plus 5x squared. Now I'm going to move over to this term. Okay, so negative x times x squared is negative x to the 3rd. Negative x times negative 4x is positive 4x squared. And then negative x times 5 will be negative 5x. Alright, now negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 4x is plus 8x. And negative 2 times 5 is minus 10. Now I need to find a common denominator. No, I'm sorry. Find like terms and add them together. So I've got x to the 4th because there's not another one. Okay. Now I'm looking at my x to the 3rd. So I got a negative 4x to the 3rd. And a negative 1x to the 3rd, so it's negative 5x to the 3rd. Now I'm looking at squares. I got a 5x squared, a 4x squared, a negative 2x squared. So 5 plus 4 is 9, minus 2 is 7x squared. Okay. Yep. And then I'm looking at my x's. So I've got a negative 5x right here, a plus 8x right here. So it's plus 3x, not squared. Won't copy that. It's just plus 3x. And then finally, I've got this minus 10 down here at the end. And that is a polynomial with these particular zeros and the lowest degree possible. Next, we're to find a polynomial of lowest degree. Has a leading coefficient of 1 that has the given graph. So it's actually identical to the last problem we did, except instead of giving you a list of zeros, I'm giving you a graph that which we can look at the x-intercept. So I have an x-intercept right here. I mean that to be negative 3. I have an x-intercept right here. I mean that to be negative 1. An x-intercept here is positive 2. And an x-intercept here is positive 3. So that means, again, let's list them. X equals negative 3, x is equal to negative 1, x is equal to positive 2, and x is equal to positive 3. Okay, well that's going to give me particular factors. That's going to give me the factor x plus 3, x plus 1, x minus 2 and x minus 3. Okay, and then we put all those factors together. So my polynomial would be x plus 3 times x plus 1 times x minus 2 times x minus 3. Now, if I were to put that on the test, I'd probably be happy right there. But the book doesn't do that. They multiply all of this out, just like we did on the last problem. So let's do that. Okay, so I'm going to multiply those two together and then those two together. So x times x is x squared. X times 1 is 1x. 3 times x is 3x. And 3 times 1 is plus 3. Okay, and then I simplify that by doing x squared plus 4x plus 3. Now over here, doing x times x is x squared. X times negative 3 is minus 3x. Negative 2 times x is minus 2x. Negative 2 times negative 3 is plus 6, which gives me x squared minus 5x. I add like terms, plus 6. Finally, I will multiply all of this out. So x squared times x squared is x to the 4th. X squared times negative 5x is negative 5x to the 3rd. X squared times 6 is 6x squared. Then I'm going to move to my 4x and multiply. So 4x times x squared is 4x to the 3rd. 4x times negative 5x is negative 20x squared. 4x times 6 is plus 24x. Okay, then 3 times x is 3x squared. 3 times negative 5x is negative 15x. And 3 times 6 is plus 18. I add all of this together. Finally, I know, so wear you out. X to the 4th. I don't have another x to the 4th. Okay, now I'm looking at my x to the 3rd. So I have a negative 5x to the 3rd here, a 4x to the 3rd here. I don't see any more, so negative x to the 3rd. Looking at my squares now, I got 6x squared and a negative 20x squared, which is negative 14x squared, and a positive 3x squared, so negative 11x squared. And I'm checking it again. A 6 minus 20 is negative 14, plus 11 is, 3 is negative 11. Now I'm looking at my x's, okay, just x's. I got a 24x and a minus 15x, so that gives me a positive, a positive, 9x. And then constant, it looks like I just have this lonely 18 at the end. So my final result, x to the 4th minus x to the 3rd minus 11x squared plus 9x plus 18.